In this video, we are going to solve 3 problems related to right triangles. This is number 1. This is problem number 1. We are given the hypotenuse. The hypotenuse is the side opposite the 90 degrees, the angle of 90 degrees. We are given an angle and we are asked to find the missing parts, which are angle A. So we need to find angle A, the length of side AB, and the length of side BC. Now we are going to solve this problem giving a writing statement and explaining, giving the reasons. So the easiest part to find here is perhaps angle A. So we know that the sum of the angle A plus angle B plus angle C is equal to 180 degrees. Now the reason is the sum of angles in a triangle. This is a very well known result. So we go now and we know that angle B is 90 degrees, angle C is 30 degrees, so angle A plus 90 degrees plus 30 degrees is equal to 180 degrees, and then we solve for angle A, and that gives angle A is 60 degrees. Now the next item that we are going to calculate is the side AB. Now the length of the side AB. Now we notice that the side AB is opposite the 30 degrees and you are given the hypotenuse. Now here we can use the sine of 30 degrees, which is given by the opposite side divided by the hypotenuse. Now remember again, the hypotenuse is the side opposite the 90 degrees. The opposite side is the opposite to 30 degrees. So the opposite side is the opposite 30 degrees, and the unknown is the length of AB. The hypotenuse is known 6. Now sine of 30 degrees, you can use the calculator. It's equal to 1/2. So we just substitute sine 30 degrees by 1/2, AB over 6, and then we solve for AB to obtain. Now let's do the cross product. This 2 times 2 AB, so the cross product 2 times AB equal 1 times 6, equal 1 times 6, and then we multiply, we divide by 2 both sides. So we divide here by 2, divide here by 2, and that gives the length of AB is equal to 3 units. Now good, we need to find BC. BC is the adjacent to the angle of 30 degrees. And here we can use the cosine. So the cosine of 30 degrees, by definition, it's the adjacent side divided by the hypotenuse. Now the adjacent side is the, I repeat again, the adjacent side to 30 degrees is BC, so length BC divided by the hypotenuse 6. The cosine of 30 degrees is square root 3 over 2 equal the length of BC divided by 6. Again, we do the cross product. 2 times BC, the length, is equal to 6 times the square root of 3. So this is equal to this. And then we divide by 2 to find the length of BC is equal to 3 square root of 3. Now just 2 more details and then we finish with this problem. Now this is written because this is due to the definition of the sine here, definition of sine in a right triangle, and also this one here, it's written, this is due to the definition of cosine in a right triangle. Now let's solve the second problem, problem number 2. Again, it's a right triangle, and this side we are given this time we are given the two sides that makes the 90 degrees. No angle is given. So let's try to find ij, the length of side ij. So we need to find ij, the length. We need to find angle I and angle J. So these are the unknown. Good. Now the statement. Now it's a right triangle, and therefore we can use the Pythagorean theorem to find the hypotenuse. Remember, the hypotenuse, it's the side opposite the 90 degrees. Good. Now the Pythagorean theorem says this: the hypotenuse, let's call it h, yeah, to simplify. The hypotenuse square is equal to the sum of the square of the two sides. So 6.4 square plus 4.2 square. Now the reason it's because I, K, J, the triangle is a right triangle. And in a right triangle we use what we call the Pythagorean theorem, which is this. Good. So here we take the square root of this side is equal to the square root of this side. Now the square root of a square gives you h. This simplifies, and then this one here, this side here can be done with a calculator. Using a calculator, this is approximately 7.66. So it's an approximation. Now let's go here and put it here, 7.66. So we know all the sides of the triangle. Now let's go and find an angle, angle I, for example. Now we have the choice. We can use the tangent, the sine, the cosine, whatever. So let's use the sine again. So the sine of angle I, this angle here, by definition, it's equal to the opposite side divided by the hypotenuse. Now this is I, the opposite is this side here, opposite 4.2 divided by the hypotenuse. The hypotenuse is this, 7.66. 7.66. Now the reason this is again a definition of the sine. Now how do you find I now? You use your calculator. So I is equal to the sine inverse, using the sine inverse in the calculator set to degrees, of course. 4.2, 7.66. Which gives 32.25 degrees. 32.25 degrees. We now need to find angle J. This is quite simple because we know that the sum of the three angles, angle J plus angle I plus the angle of 90 degrees, this should give the 180 degrees, the sum of 100. Now the reason is the sum of angles in a triangle. Now this is a very well known result. Now we substitute, so angle J, angle I we just found here, 32.25 degrees plus 90 degrees, that gives 180 degrees. Now when we solve this, we get angle J is equal to the value of the angle, the size of the 56.75 degrees. So we have all angles, all the sides of the triangle, and here we have finished solving this problem. Now we solve problem number 3. Now in problem number 3 we are given a triangle with two sides that are equal. The length of PQ is equal to the length of OP. So this side equal to this side. So let's go here and say the length of OP is equal to the length of PQ, and this is given. Now, when two sides of triangle are equal, we call this triangle isosceles. So triangle OPQ is isosceles. And therefore, when a triangle is isosceles to the angle O and the angle Q, now the angle that are opposite the angle, the equal sides are also equal. So angle O is equal to angle Q. Now the reason here, it's because the triangle is isosceles. Okay, now let's call angle O equal angle Q, and let's call them alpha, because they are both equal. Now, let's find these angles O and Q by using the well-known result that angle O plus angle Q plus angle P is equal to 180 degrees. The sum, now the reason here is the sum of angles in a triangle. The sum of angles in a triangle. Good. Now angle O and angle Q, this is a Q, are both equal to alpha. Alpha plus angle Q alpha plus LP 90 degrees equal to 180. Good. Alpha and alpha, that gives me 2 alpha equal 180 degrees minus 90. I subtract 90 from both sides. That gives me 90. I divide by 2, and that gives me alpha equal to 45 degrees. Now remember here what is alpha. Alpha is also angle O and angle Q. So we found all the angles in a triangle. Now we go and find the length of P and PQ. They are equal, therefore let's call the length X here and X here. Now we are going to use the Pythagorean theorem. Which says that the hypotenuse, this is the hypotenuse, which says that the hypotenuse square is equal to the sum of the square of the other side. So it's x2. So this square, the hypotenuse, is equal to this square plus this square, x2 plus x2. Now the reason here, it's because OPQ, it's a right triangle. It's a right triangle. Good. Now the hypotenuse, we know it's a 5 power 2 equal to x2. Now we divide the two sides by 2. That gives me, this simplifies to x2. The other side, 5 power 2, gives me 25 over 2. To find the x, I will have to take the square root of x2 is equal. So I take the square root of this side equal to the square root of this side. Now the square root of the square, we know it simplifies to x. Yeah, this comes from the fact in algebra that square root of x equal to x. Of course, assuming x is positive here or 0. Good. It cannot be 0 anyway. So square root of 25 divided by square root of 2. That gives me 5 over square root of 2. Now we don't like the square root in the denominator. So what we do, we multiply by the square root of 2 here, we multiply by the square root of 2 here, and x is equal to 5 square root of 2 divided by, now let's go here, square root of 2 multiplied by square root of 2. This gives me 2. This will simplify to 2. And remember, these are the side OP and PQ, and they are equal. OP and PQ. So with this, we have finished solving the triangle given to us.